All right, so you've done it. You've broken up that big old monolithic application into a bunch of smaller, shiny microservices. That's awesome. But now you've got a whole new set of questions, right? How do all these little services actually talk to each other? How do they even find each other in the first place? And how do you make sure all that communication doesn't just turn into one giant system-crashing traffic jam? Well, that's exactly what we're going to unpack today.
But before we dive into the deep end, we need to get one thing straight. It's what I consider the guiding star for all of this, the first law of software architecture. And it says, everything is a trade-off. There is no magic wand, no perfect solution that solves every problem. Every single pattern we're about to talk about has its upsides and its downsides. So our goal isn't to find the best way, it's to find the least worst way for what you are trying to build.
And this is why this whole conversation matters so much. Because if you don't think about communication on purpose, you could end up with, well, this, the dreaded big ball of mud. It's what happens when everything is tangled together, nothing has a clear boundary, and making one tiny change feels like playing Jenga during an earthquake. This is the mess we're trying to avoid.
So how do we dodge that chaos? We've got a roadmap. First, we're going to look at the two main highways for communication, the direct, synchronous path, and the more flexible, asynchronous one. Then, we'll get into how you coordinate everything. Do you need a central boss calling the shots with orchestration, or is it more of a free-form dance with choreography? And finally, we'll put it all together so you can figure out which trade-offs you're willing to make and choose the right path.
Okay, let's get into it. First up, we've got the synchronous path. And honestly, the best way to get this is to think of it as the phone call model. Think about it. When you make a phone call, you dial the number, you put the phone to your ear, and then what do? You wait. You're blocked. You can't really do anything else until the other person answers, you say what you need to say, and you both hang up. That, in a nutshell, is synchronous communication. One service sends out a request, maybe using something common like REST or a faster protocol like gRPC, and it just has to sit there and wait for the answer before it can do anything else.
And this visual, man, it just nails it. Look at that. The service on the left, the producer, sends its request, and then nothing. It's stuck in that wait state. It is completely frozen until the consumer on the right finishes its work and sends a reply. From a user's perspective, their whole experience is held hostage by that entire round trip.
So what's the trade-off here? Well, on the one hand, it's pretty simple. The code is easier to write and think about, because you get an answer right away. Either it worked or it didn't. But the downsides? They can be huge. Your services are now tightly coupled. If service B is slow or goes down, service A is dead in the water. This can create a domino effect, a cascading failure that takes down your whole app. That's actually why we have patterns like the circuit breaker, to basically flip a switch and stop one failing service from causing a pileup.
So, if synchronous communication is a phone call, what's the alternative? Well, that brings us to our second model, the asynchronous path. Think of this one as the text message model.
I mean, when you send it text, you don't just lock your screen and stare at it waiting for the 3 little dots to appear, right? Of course not. You fire off the message, put your phone away, and you go on with your life. You've made your request, and you'll get a little buzz in your pocket when a response is ready. That is asynchronous communication. The sender is totally free to do other things right away.
And check this out. This diagram shows you the secret sauce. The producer doesn't call the other service directly. Nope, it just drops its message off with a middleman, like a message queue. Think RabbitMQ or Kafka. And then it immediately gets the green light to go and do something else. The work still takes the same amount of time in the background, but for the sender, it felt instantaneous.
An effect this has on the user experience, it is just wow. It can be absolutely massive. In one of the examples we looked at, a task that took over 3 full seconds with a direct synchronous call felt like it only took 25 milliseconds to the user when they switched to an asynchronous pattern. That's not just a little better, it's over 100 times better. That is a game changer. But of course, with great power comes great trade-offs. The benefits are huge. Your services are decoupled, which makes your whole system way more resilient and easier to scale. But the downsides are real too. The code is just plain more complex. It's harder to track what's going on. And you have to get comfortable with this idea of eventual consistency, which means your data will be correct eventually. Just maybe not in the exact microsecond the user clicks the button. Okay, so we've got our methods, the phone call or the text message. But what happens when you have a bigger task, like placing an order online that needs a whole bunch of services to work together? Who's in charge of that whole process?
This is the big coordination puzzle we have to solve to avoid that big ball of mud. And there are two main ways architects think about this: orchestration and choreography. And the difference really boils down to this. Is there a central brain telling everyone what to do, or does each service just know its part in a bigger dance?
Orchestration is exactly what it sounds like. You have a conductor. There's a central orchestrator service that acts as the brain. It says, okay, first you, order service, do your thing. Now you, payment service. Now you, shipping service. It's great because you can look in one place and see the entire workflow. Choreography, totally different vibe. Think of a dance floor. Each service is independent. The order service just yells order placed, and any other service that cares about that event, like payment or shipping, hears it and starts doing its own dance. It's incredibly decoupled, but it can be a lot harder to see the whole picture from the sidelines.
And this slide right here, it's a perfect example of choreography in the wild. A request comes in from the user, probably through an API gateway, asking for all the customer's data. The first service gets it, but realizes, hey, I only have their wish list. So what does it do? It calls the customer demographic service directly, gets the info it needs, stitches it all together, and sends it back. No central boss needed. The services just knew how to work together.
So we have our communication styles, sync and async, and we have our coordination patterns, orchestration and choreography. Now it's time to bring it all home and face the great trade-off, where we really have to decide what's most important to us.
This table lays it all out, clear as day. If you absolutely need simple code and rock-solid, immediate data consistency, then the synchronous path with something like REST looks really good. But if what you really care about is blistering performance, massive scalability, and a system that won't fall over if one part of it hiccups, then the asynchronous, event-driven world is calling your name. It really is a classic showdown, simplicity versus power and resilience.
So, with all of this on the table, with all these trade-offs staring you in the face, how in the world do you actually choose? How do you pick the right path for your system?
And this brings us back to what might be the single most important piece of advice in all of this. Don't waste your time trying to find the best architecture. It's a myth. It doesn't exist. Instead, your goal should be to find the least worst one. And what that really means is you have to consciously pick the set of problems and compromises that you are most willing to live with. So here's the bottom line. Your context is everything. Don't just pick a pattern because it's trendy. Ask the hard questions. Does a user absolutely have to see their new bank balance the instant they make a transfer? Okay, you probably need strong consistency, which points you toward a synchronous call. Can placing an order kick off a bunch of background tasks that don't need to happen right away? An asynchronous approach is going to give you way better performance. And as your system grows, managing all this stuff, service discovery, circuit breaking, is exactly why advanced tools like service meshes, things like Istio and Linkerd even exist, to handle the messy communication details so your services can just focus on their jobs. Which leaves us with one last question for you to think about. When all your services start talking, is it a smooth, flowing conversation, where messages still get through even if one person is busy for a second? Or is it a fragile, gridlocked traffic jam, where one stalled car brings the entire highway to a screeching halt? The choice is yours.